All right, so let's go ahead and continue where we left off last time. What was our big topic for yesterday? Yeah, so yesterday we talked about continuity. Today we're going to continue talking about continuity. So we're going to pretty much finish up our section where we talk about what does it mean to be continuous. So this is going to be something like continuity continued. Continuity continued. So let's recap. What did how did I check for continuity at a single point? I had three things. What was the first thing? Yeah, to see is the function defined at a point. So to check for continuity at a point, this is what we did last time. Let's say call it x equal to a. We had three conditions. One, f of a exists. I might have used c last time, but same idea. So if I plug in my value, does the value exist at all? That was my first condition. What was condition number two? Yeah, the limit also existed. And I might use the word f of a is defined, but exists being defined. For our class and purposes, we're kind of using them interchangeably. So the limit as x approaches a of my function also exists. And then condition number three, what was the third condition? Yeah. So in other words, my third condition was my function at the point isn't equal to my limit. That is, if I write it, let me push this up, f of a is equal to the limit as x approaches a of my function. Oops, not c, x. So these were the three things I was looking for. So in order to be continuous at a point, I need all three conditions to hold. If even one condition fails, then everything fails. It tells me that I am not continuous at that point. So one problem is enough to ruin continuity for us. And we talked about why is it so. Really, our true definition of continuous was this third one. But we said if one fails, then it doesn't make sense to say that it's equal to anything. Same thing for two. If the limit doesn't exist, there's no way we're going to say something doesn't exist equals to whatever else. So these were our three general things that we went down the list for. And we did an example with it as well. So this is our recap of what we've done on the previous lecture. So let's go ahead and continue into our next portion of continuity. So a definition. And we kind of talked about this last time. I might say a function is continuous. Oops. Is continuous on an interval I if f is continuous for every point in I. So we say a function is continuous on an interval if for all the points inside that interval, I am still continuous. So we're expanding our definition a little bit. Before we had continuity at a point. Now we're expanding it to continuity on an interval or a range of numbers. And this is where our wording will be important. Remember we said overall something's not continuous versus if I restrict a domain, it's continuous. So, oops, where'd that L go? Red. So, whenever I talk about continuity, in general, I should be specific. Am I talking about, is it continuous overall on all real numbers? Or is it continuous on this interval? Or am I talking about continuity at a single point? So a point, an interval, or just across all real numbers. Something could be continuous at a point, but not continuous on an interval that we've chosen. Similarly, something could be not continuous. Well, let me reword this. It could be continuous on an interval, but not continuous across all real numbers. It depends on what we're choosing to be our interval. It's also possible that I'm discontinuous all the way through. So we're going to go ahead and deal with some examples on intervals of continuity. How can I find all the numbers for which I am continuous? So let's go ahead and do this next example. I'm going to keep this definition on the board for anyone that wants to write it, but eventually I'm going to move it up. Example. Determine the interval of continuity. The interval of continuity for the following. Let's start off with part A. What if I have the function, let's start off with this, f of x is equal to, let's do x minus 3 all over x squared minus 4x plus 3. And now let's move this up. Let's start off with part A. So whenever I'm asking for the interval of continuity, in other words, I'm asking what are all the x values for which my function is continuous. In other words, I don't have any jumps, no holes, or anything. So in order to find the values that work, it may be easier for me to just identify the numbers that do not work for me. So how can I figure out what values am I not allowed to use here? What are some ideas? Yeah, let's see if we can try to factor the denominator. Let's use the red. On the top, there's not much I can do. On the bottom, what's the bottom, the denominator factor into? We had x minus 1, x minus 3. I would agree. Negative 1 times negative 3, we get positive 4. Negative 1 plus negative 3, we get negative 4. All right, so to find these points where I'm not continuous, should I do my cancellation? No, because remember what I said last time. We need to be a little bit careful when we're talking about our points of continuity, or discontinuity to be exact. Because whenever I do that cancellation, technically it gives me a different function. So really, in this case, I was not worried about the numerator, the top at all. I was really only concerned about the denominator, the bottom. So keeping that in mind, what should I do with my denominator? Well, what do I not want to happen? What do I want to avoid? We don't want the denominator to be 0. In other words, again, moving this up, I want to make sure that x minus 1 times x minus 3, that's a weird x minus 3 is not 0. Because if it is 0, we have a problem. Well, from here, I can go ahead and try to do some algebra. I have something that's factored. I can say, then I want x minus 1 is not 0, and x minus 3 is also not 0. So from the left, what result do I get from the left equation? Yeah, we want to make sure that x is not 1. And we can check that. If I plug 1 into here, I get divided by 0. It's a problem. And what about on the right? We want to make sure x is not 30. Perfect. So now the question is, how do I write this in interval notation? To help us figure this out, especially if you're not used to interval notation, let's draw a number line really quick. On the left, we have negative infinity. On the right, far right, we have infinity. The numbers we were looking at were 1 and 3. So based off of this, I want to make sure I can use any number except 1, except 3. This is not what you would normally do, but just for visualization. I don't want 1. I don't want 3. Am I allowed to use the rest of my numbers in this function? Yes, certainly. I can use the rest of my numbers here. So if I look at this number line, I have 3 natural groups, right? The left side, the middle, the right. So if I want to write this in interval notation, my first interval is negative infinity to 1. So let me write that. Let's minimize that. Let's write negative infinity to 1. What's my second interval based off what I'm seeing here? Technically both correct answers, just different order. We have 1 to 3, because I can use those numbers in between. And I also got 3 to infinity. So this is me saying, if I use any of these numbers in these intervals, the board does not want to cooperate very well today. Between negative 1 to infinity, between 1 to 3, or 3 to infinity, I'm not going to have any issues, because we identified which numbers give us the problems. We know that 1 gives me a problem, 3 gives me a problem. I claim that this will give me my interval, or intervals, plural, of continuity, these 3 right here. And if I want to be really formal, I could use this notation. Has anyone actually seen this little U notation? It means union, which basically means this one, or this one, or this one. Again, if you haven't seen this, this means union. Union. I claim this to be my interval of continuity. Interval, intervals, however you want to say it, how technical you want to be. Why do I think nothing between negative infinity to 1 is going to, how do I know that nothing there is going to give me a problem? It didn't come up in my denominator. And I know from the previous day, the things that gave me issues in continuity is whenever I had a hole or an asymptote. Well, from the denominator, these are the only things that might give me a hole or an asymptote. In other words, by setting the bottom and say, I don't want that to be 0, I've accounted for those holes. I've accounted for the asymptotes. So this will be my interval of continuity. In other words, I was checking to see for what values does my function exist in this case. Any questions about what I have here before I go on to part B and eventually part C? All right, let's go to part B. Same instructions. What if I have g of x is equal to the square root of x minus 4? I'm going to ask, what restrictions do I have on this type of function? What do I want to avoid? Let's see. If I'm talking about a square root in particular, what do I typically want to avoid whenever I'm dealing with a square root? Negative numbers. What about 0? Am I allowed to take the square root of 0? What's the square root of 0? 0. So I'm allowed to take the square root of 0, right? There's nothing wrong with me doing that. The issue is really, at least in real valued calculus, is taking the square root of a negative value. In other words, whatever's inside my square root, I want to make sure that it's not negative. Or in other words, written in this way, I want to make sure that, again, whatever's inside my square root, not being negative, that means greater than or equal to 0. Isn't that the same thing as saying not negative? Yes. If you're bigger than or equal to 0, that is equivalent to me saying not negative. Because if this whole thing is smaller than 0, it must be a negative number. I would have the square root of a negative. We have some issues with our real numbers. All right, so again, this is a little bit of a recap from algebra. How can I solve for x here? This, what was it? X minus 4 greater than or equal to 0. What do I need to do? We can add 4, right? Because x is already alone, almost already alone. If I add 4 to the left and to the right, I get x is greater than or equal than 4. Now my question is, how do I write that in interval notation? Does anyone remember interval notation for this? Just to help us, we can draw the number line because it helps us visualize what's going on. You don't always have to draw the number line, but it is good as sort of a refresher. I always like putting infinity and negative infinity on the two sides. And what number are we interested in? 4. So let's put 4 on there. If I want the numbers bigger than 4, am I looking to the left or to the right? To the right. So I'm not worried about this portion. So I heard a 4 comma infinity. Now the question is, am I going to be using parentheses for both of them or one of them or so on? So let's do a quick recap of interval notation. You have two options, a parentheses, the round ones, or the square brackets. What was the difference between those two? Yeah, so square brackets means that you included the number. Parentheses means that you exclude the values. So we are including 4. So let's put a square bracket on the 4. What about infinity? I hear some parentheses, I hear some brackets. I'm going to say parentheses, but why?